called stratification stratification analysis and root cause analysis. So as Hector said, my name is Keith Fong. I think all of you know me on the call anyways. And this is going to be the presentation for our member meeting in May 2024. So for those who don't know me, I'm a consultant and trainer. I have a little consulting company, and my background's in product design engineering, and I was a continuous improvement coach at Delphi for 20 years or so. And then I'm certified as a Shainin Red X Master, Six Sigma Master Black Belt, and a robust engineering coach. And I also have a little podcast called Way of the Quality Warrior, where I talk about topics related to quality, specifically what I believe is the role of quality. So let's go ahead and get started. The agenda for this presentation is we're going to talk about the many names of today's topic, where we apply it, context and strategy. So, all tools have their strength in being used in the right place in the right way. I'm going to go through an example that's technical, and then I will also do an example that's transactional, which is transactions relate to like information and services. And then we'll do a quick summary. So with that, the many names. So as I said, the title for the presentation, Stratification Analysis in Root Cause Analysis. So that's one name. You might also know this methodology as families of variation analysis. There's another name, nested components of variation. Shainin calls it the strategy diagram. In fact, that's where I first learned it. And the new science of fixing things calls it the Matryoshka strategy. There are more names, I'm sure, because in the world of quality, everybody has their own name for this. So if we look at the generic problem-solving journey, right? So every problem-solving method goes through these same steps. For if you're talking about 8D, or you're talking about Six Sigma DMAIC, you're talking about the Toyota A3, whichever ones. You first have to have problem identification. What's somebody's unhappy, right? At the very least, there's somebody's discontent, and then we go through the stage of converting that discontentment into a problem that the team can actually work on. And from there, we have to verify that we have a reliable measurement system. Then we go through the root cause analysis, figure out what is causing this failure. And then we get to, once we know the cause of the failure, the corrective actions to either control or correct it, implementation of those corrective actions, and then sustainment of the corrective actions. This presentation is focused specifically on the root cause analysis, and not just root cause analysis, but like the very first step of root cause analysis. So in root cause analysis, we should have a strategy. And the strategy that I want to encourage all people to use is the process of elimination. And in the process of elimination, the focus is on eliminating possibilities. Amateurs focus on finding the cause. And that means they get to the cause mostly by guessing. It might be an educated guess, but it's still a guess. Like, oh, we have this problem, it must be that. Or we have this other problem, it's got to be this thing. And not necessarily going through a rigorous process. So in the process of elimination, as I said, our focus is trying to say, oh, where is the problem? Not so that we focus where it could be. Now, there is a foundational belief in all problem solving, and that is the idea of cause and effect. So, mathematically, we might say that as y is equal to the function of x, right? We all learned that in math in high school. So the other thing that's really critical for us to understand is that what is a problem very much depends on your perspective. Where are you on the hierarchy? And most of us in this ladder of abstraction, the very top levels, the very abstract ideas, like in this case, wealth. But then you get down to the very concrete things like, something that's physical, touchable, and, features and settings and so forth. Most of us actually work on the lower end of this, and that is actually where problems get solved, right? For us to do root cause analysis, we have to be looking at functions, parts and processes, and features and settings. You're not going to solve a problem that is, say, profit. We're losing money. Okay, well, I've never solved a problem of excess cost or failure to make a profit, but I can solve another problem, and one of the consequences is that we start to make money or we don't lose money. But again, where the problem is depends a lot on your perspective, and in defining the problem, we have to be careful not to define it at too high a level of abstraction. We have to be working on the things that we can deal with, which includes the functions, the parts, the process, the features, and the settings. This is really, really important. So I said y is equal to a function x. For us to solve the problems, we need to have y's that we can use. And so the first category of y that we might use is energy transformation. So you're talking about things like flow or force, speed, current, voltage, right? Things of physics of the transformation of energy. So in this case, we're looking at mechanical, hydraulic, uh, electrical, but we could have chemical in here, magnetic, and so forth. But again, there's like this transformation of energy from one state to another state. Now, another category is geometry. Like when you create a part, you're molding them or you're machining them or you're using 3D printing, right? You can have something that's not okay. Your y, your effect, your y, your output could be wrong, and it could be wrong in things. It's based on the datums, like things like length, radius, forms. If you're into GD&T, there's all kinds of things that in the geometry of the thing that you're creating is not okay, and that can be the driver of your root cause. Then there's things like material property, things like strength, color, density, viscosity, conductivity. So again, we're looking at different kinds of properties: mechanical, uh, uh, fluid, electrical, uh, color would be optical. So again, the property of materials may not be satisfactory. And again, that might be what we use for the why for our root cause analysis. And then there's the category of defects, things like cracks or voids or stains. So these tend to be related to property, where, for example, a crack is your continuity of your material is interrupted, right, by a crack. Or a void, right? So like when you're doing injection molding or soldering, you get these little pockets in there, and then that can reduce the strength of the part, or it can make it unsightly. So those are important things, and we see a lot of these. And related to defect, and what's going to be we'll talk about in this presentation also, is transactions. A lot of times we have in transactional, especially information, errors, missing info, late, where you really have a binary state. It's okay or it's not okay. So, for the as I first presented these are all really physics oriented, but within defect, you're also looking at uh, uh, errors, that happen in transaction, or dissatisfiers that happen in transaction. So we're going to look at an example from energy transformation, and we will also look at a transactional example. So let's expand a little bit on our foundational belief of, y is equal to a function of x. And that is, y is not equal to a function of x, but y is equal to the function of x1, x2, x3, so on to xn, as n goes to infinity. So there's not just, one thing produces, one input creates one output. It's like a few things have to come together to produce the output, right? So if you're talking about baking a cake, you're going to have to say, well, I need all these different ingredients, your egg, your flour, some kind of fat, maybe sugar, maybe some kind of flavoring. You need your pans, you need your ovens, you need your mixing bowls and so forth. So you have all of these things that need to come together to produce a cake. Again, if your output is a cake, there's a lot of inputs into that. Well, the important thing that we have to understand here is, yeah, you might have an infinite number of potential causes or inputs, but only a few of them are actually critical. So This is a really, really essential idea of problem solving. You can't have lots of things causing a problem. It's generally coming down to one or two things that are among the critical ones that are not okay. So we need to talk about what is a problem. And let's say we're doing something that has a target value. And if we hit the target, right, we're happy, right? It's the why is just right. It's what we want. It's kind of the Goldilocks thing. It's just right. Now, it's possible that what you want, the target you're shooting for, you get a value that's too high. And that is a problem, right? Because it's making you discontent. It's not satisfying your expectation. Similarly, when you have a target, you can have an output, a Y that's too low. So a problem is really the difference between what you want, the just right, and what you actually get, like in this case, the too high. But it's also a problem if what you want is just right, but you get the too low. So you have two problems represented here, too low, too high. Now, if we looked at this, right, if we look at the equation, we see that y just right is a function of x1, x2, x3, x4, x5, and x6, right? The same y for too low is a result of the same factors. The y too high, again, the same 6 factors. Now, what we know is there's the usual suspects. When we have a problem, we generally know what are the more common drivers of our output not being okay. So it's a X1, X2, X3. Those are the usual suspects. And maybe we also know that there's a couple other factors that are important, but maybe they're very capable. They don't change very much. They're very stable, and so they're rarely the source of a problem. So we could say these are the known critical factors. But what happens if there's a sixth factor that is the real cause of the reason that we have a Y just right, a Y too low, and a Y too high? And maybe, just maybe, it's not known to be critical, right? It's known, perhaps, but we don't realize, oh, this is actually important. So if we look at these factor x6, the x6 for the just right y is not the same as the x6 for the y too low, which is not equal also to the y too high x6. And so the important thing here, the y's are different because the x6 is different. And of course, in this example, x6 is the root cause, right? The explanation for all of that variation. So again, we're going to go back to our strategy is the process of elimination. How do we quickly eliminate where the root cause, in this case, Rx6, is not? And the way we're going to do that is look where the Y too high and the Y too low appear in the same families. Because when we see that, we know that our root cause, our X6 in this case, is seeing its extremes. Every other family, we can discount them. We don't have to spend our time investigating those areas. So we can save ourselves a lot of time, a lot of effort. And also with people who are hung up on, oh, it's got to be this thing, right? There's so many people who come into a problem and they have their favorite problem cause and they're just hung up on it. In the face of all kinds of evidence, they just don't want to believe. They're like, well, it's got to be this. It's like, well, there's no evidence that supports that. No, it has to be, right? So this can help you in dealing with those cases. So problem solving power, right, is important. We need to get as much power to solve this problem as we can. And the way we're going to do that is using the Y too low and the Y too high to help reveal what is this root cause, this critical X. And the important thing here is, remember, y is a function of x's. And the difference between the Y too low and the Y too high is delta Y max. So we end up having the maximum change in our output, right? The larger that difference is, that means that the X that's driving it is more different between them. So the value of the X6 for the Y too low is the most different from the Y too high's X6. So that makes it easier for us to find it. So again, using the delta Y max means our delta X, root cause, in this case, our X6, is also as large as it's going to be. So this is really powerful for us. And if we leverage this, we can accelerate our problem solving process. So again, I guess I'm just repeating that. The larger the delta X is, the easier it is to find. So we're going to look at to do stratification. The challenge for almost everybody is to be able to stratify all the possible X's. You have all, again, the number of X's goes to infinity. So the question is, how do you break it down so that you can say, well, actually, I'm dealing with the smallest family, and then, I'm incorporating more. Sometimes I tell people it's kind of like saying, maybe you have a joint problem in one of your hands or your fingers, right? So you could say, well, I have a joint problem. Do I have a joint problem in, my index finger, first knuckle? And then is that the same? Does it occur in the same finger on the same hand? Does it occur in different fingers on the same hand? Does it occur in different hands? Does it affect, hands? Does it affect feet also? Does it affect like my siblings? Is my sibling affected? Are my parents affected? Grandparents, cousins, and so forth. So you start spreading out. Again, this is where families of variation comes from. So it's trying to figure out what is the smallest family where I could possibly see the delta Y max, right? Again, this is where a lot of people struggle in the learning process, is like, how do I identify what's the smallest family? And then building out from there. So there's 4 basic types of families that you'll be looking at. So there's elemental. So like, what's different within a single cycle? Cyclical. What's different between cycles? Structural. So if there's parallel paths, right? If there's more than one path to do this, does one path have it and another path that doesn't? And then there's temporal. So does it happen at one time and doesn't happen at other times? And I don't think it takes a whole lot of reflection to think of examples that you've probably experienced in every case where, oh, you know what? When I get parts from this place, these 2 places supply the same parts. This other part here, they're always good. This other part here supplies variable parts. Sometimes they're good, sometimes they're bad. Well, that would be a structural issue. Whereas a temporal one is like, hey, in the morning it's okay, in the afternoon it's not, right? So that's temporal. Or what happens, last month versus this month. Cyclical might be, oh, my thing is moving one at it cycles, every 10 seconds or something, and some cycles are okay and some cycles are not. And then of course elemental is within just one thing do you see the extremes. So really important ideas. You don't necessarily have to understand these very clearly, although it's helpful as you lay out your family's variation. So let's do an example of an analysis of families variation. So in this case, as I said, we're looking at an energy transformation. We're going to look at a flashlight, and the measurement units that we're using with this flashlight are lumens, right? Like, how bright is the light coming out of it? And then our evaluation condition is we're going to, run it for 2 minutes. So we just, we've done our studies, and our customers tend to only use it for a couple of minutes, right? To light. That's the general use case. That's the most common use case. So that's one we're going to work with. Now, the target, what we want is to produce 300 lumens. And what we've seen is some of them are producing 360 lumens. So they're brighter than what they're designed to be. And then we also have ones that the
Bueno,
output is 180 lumens. And so with that, we have a low output. So again, we're not hitting our targets. So again, we want to hit our target, but we're seeing that we have both high and low values. So the first family is to think about is, well, first we got to pick a bad one, right? We have parts that are too high, parts that are too low. I'm going to take the too low. All right, I'm going to just use that to work with. So with my flashlight, which is putting out low amounts of light, I'm picking that because it's further from the target value of 300 lumens, being 180 lumens, and it's also a greater dissatisfier, right? When a flashlight isn't as bright as you want, it's like, hey, this isn't. I was expecting better vision, and it's not helping me. So it's again, I'm sort of arbitrarily picking one in this case, but it seems like it's the one that works better for me. Now, as I said, we ran a test for 2 minutes. So what I want to do is look at its behavior across the 2 minutes. Like, how does it change within a one single test? And we measure the lumens output, and there's variation, but not a whole lot. And if we compare that against the whole range, right, our delta Y max, we know is 180 to 360. If we look at that, we can easily see that we're using just a tiny fraction of the possible variation of the observed variation. So this tells us that the X, well, what we can conclude from this is there's really no change in the Y during the cycle. So that means the X driving that variation of 180 lumens to 360 lumens, it's stable. It's not changing. It's not moving us between 180 and 360. So it's hard to find a root cause if it's, not changing, because you could change 50 things, all of them are stable. Maybe one of them's the cause, but that's a bad practice. Okay, so this is the first family. This is the smallest family. You don't have anything we can leverage here. So let's increase the size of our family. Well, when you test something, what do you usually do? You test it again. So what we do is we're going to look at this in again using the same sample, but this time we're going to test it multiple times with so it's cyclical variation within the unit. And what we want to see is, if I turn it on, run the test, turn it off, and then run the test, turn it back on and run the test again, and turn it off and run the test again, how much variation do we see? So we run the first one. It's basically the same as the previous. We run it again. No change here. We run it a third time. And again, if we look at the delta Y max, we are using none of the range. I mean, it's such a little small fraction. So this like, what are we going to conclude here? Again, we don't see that the Y is changing during our repeated tests. So that tells us that the X root cause is unchanging, that it's stable. So, again, if it's not changing, it's hard to see. So we got to expand our family, right? So first we tested one cycle across multiple cycles. Now we're going to look at multiple flashlights, right? So we're going to look at the Y2 low samples and consecutive samples from the same production line at the same time. And so we're just looking at their output on average. And what we see here is we test a bunch of them, and we have two that are low output, or at least very low output. And again, we're looking for the most extreme parts. We're looking for the Y2 low parts. We're not looking for parts that are, instead of being 180, we don't want, if we can avoid it, we don't want to use the 220s or the 230s. If there are 180s available, we want to use 180s. And so in this case, we see a couple of those, but we don't see any 360s. So we can see here that the delta Y that we see is a little more than half the total variation, but it's not close to being the delta Y max. So there's something here, but not enough. So our conclusion is, the delta y is less than the delta y max. So that means our delta x root cause is less than it could be. So we don't have really good problem solving leverage. So let's add another family. So we've done, again, one cycle, cycle to cycle, flashlight to flashlight. Now we're going to go uh, manufacturing line to manufacturing line. So we have two production lines, and we're going to take parts that are run at the same time when we found the two low samples and see what that is. So we have line 1 and line 2. So we get our data from line 1, and we say, okay, yeah, we have a 180, right? Because again, we picked it from the same time as we got our low one. And then from line 2, we see, hey, wait a second, there's a 360 on that line. So we actually are seeing the delta y max. So whatever is causing the low one on line 1 and the high one on line 2, it's there now. There's something different between those two lines, right? I don't know what it is, but there's something different. So our conclusion here is that the delta y max has been observed between production lines and that our delta x root cause is at a max. So it's going to be the easiest for us to see. Now we are going to stop here. I mean, this is promising, but there was another family that I want to take a look at. So because here we did flashlight to flashlight, and then we're switching to two different manufacturing lines. But on one manufacturing line, I'd like to see the cyclical, the temporal. Uh, so if we go back here and we say, hey, let's look at from the Y to low production, but at different shifts. So we can go back here. We have shift 1, shift 2, shift 3. And when we gather our data, shift 1, we see the very low one. Shift 2, we don't see any at the very lowest, but they're not that high. And then shift 3, we actually see a high one. So even without changing the line, on the same line, what we see is that we do have the delta y max. So that's promising. And our conclusion is that we do observe the delta y max between shifts 1 and 3 on the same production line. So the delta x root cause is at the max. Now, again, we said that we've seen the max delta y between production lines and between shifts on the same production lines. They could have the exact same cause. They could have potentially different causes, but it gives us a place to look, a place to focus. So, when we just looked at the flashlight, there's a certain number of X's involved. And then when we repeated it, we brought in some more potential factors like, turning the switch on and off, right? Maybe there's something in the testing. So there are a few more potential causes came into the mix. And then when we went to flashlight, now we're bringing in some more potential causes like variation between components between the two, variations in the setup. Then when we talk about two different production lines, we're adding in there the production line conditions, the operators, the fixturing, the setups and so forth. And then if we think about the same line but multiple shifts, we're also bringing in a few other X's, potential causes. So that's the idea of the stratification is we want to find out, like, get the smallest set of the reason we start with the smallest family is because we want the smallest number of potential causes first, because the fewer that we have to deal with, the faster we solve the problem. And we also want to do it in a structured way so that we're not doing things like, oh, well, I want to compare between two lines when maybe just in turning on the same part on and off, you get the full range of variation. Then it doesn't make sense to be looking at the production lines. But in this case, we see the greatest amount of variation when we are dealing with, production line, or shift to shift on the same production line. So, kind of signals something in the process. And that's how we could focus ourselves. Now, I want to look at a transactional project, right? So everybody is doing transactional projects of some form. We are doing transactions all day. So if you look at processes, even in the most, how should I say, manufacturing intense facility, I would argue that manufacturing processes are heavily outnumbered by transactional processes. You know, I know every single plant and every single company, they must have their, human resource stuff. They have, so you have your process of getting paid, you have your process of getting vacation, your health insurance, life insurance, uh, whatever governmental regulation things are required, things like security, things like shipping and receiving, maintaining inventories, so all of these things are transactional. We're talking about service, we're talking about um, information, right? So, if you go to a hospital, they do, they're just loaded with processes that are transactional. And so this is one of those areas where even if you're solving a technical problem, if you really dig deep, you're going to end up in the office and you're going to end up with something related to transactions. There might be an issue where there's not, like for example, your parts are out of specification and then you dig into it. Oh, it's because we did not send to our supplier the updated drawings, right? Now, the physical manifestation of your transactional process failure is a physical part process failure. But as I said, it's just crazy to me. There is so much opportunity for improvement in transactional projects, and they're actually kind of easy. Especially once you get the hang of like identifying where it could be coming from. And frankly, there's not all that many possibilities. So in this case, everybody deals with orders. Like we make orders, we receive orders. Whether everybody does, everybody does. So there's not a single organization I can think of that doesn't do some kind of ordering. Either as the requester or as the supplier, or often both. So again, we're talking about information service, and in this case, we are going to use the measurement units of counts, because the evaluation condition is going to be whether, a piece of data is correct in the order or not, right? It's not uncommon to have such things. So now in our case, the target Y is 0, right? We don't want any incorrect information on our orders. And let's say we find orders, there's up to 7 pieces of incorrect data. And the low Y is 0, but it's not like we're going to say, oh, it's a low Y and it's dissatisfying. That's our target value. So we're basically one-sided here. 0 is ideal, less than 0 or greater than 0 is not okay. So if we look at an order form, right, they've got a bunch of different fields on it. And hey, we're looking at the order, with 7 errors. And I highly recommend, getting the form itself and, giving it this can be called a measles chart or concentration diagram, but mark where you find the errors. And so in this case, we say, oh, you know what? On the top half of the document are most of the errors, and there's one near the bottom. And, these are attribute. Is it correct or is it not correct? If it's a little bit, if it's not acceptable, it's just an error. A lot of times you don't necessarily want to say, well, it's almost right. Just be hardcore about it. Yes, no, make it attribute. And this is elemental variation within the structure, because when we have an order, the thing about an order is it has different parts to it. You think, oh, it's just an order, but no. We need to break it down to even smaller families of variation. And so if we just look at one part of this order, the top part where we see the most, see 4 errors, then we say, well, is that all the fields, or are there fields that are not erroneous? So in this particular case, there might be 10 fields to fill out, and it seems like 4 of them have, incorrect data. but that they're all within the same thing. So this could be just for the sake of discussion. Let's say it's the requester information, right? And maybe the error is their account number, their department number, right? So anyhow, we discover like some of it's not okay, but then others of it is okay. So we see here that within the same category, some of the data is incorrect and some is correct. And now where does that leave us? Well, we have a large delta Y and the root cause could be active here or is active here. Now we go on. Again, that's one small family variation. Well, what's bigger? What's a bigger family variation? Well, again, we're talking about the attributes. We're still looking at the same sheet. And one of the things is we looked at one category. As I said, that might have been information about the requester. But there's another section, and maybe this is information about what we see is we have one where we have a lot of errors, and then we have a category where we don't see any errors, right? So this first category, we see it has incorrect information. And then the second category has only correct information. Now, again, I don't show it here, but I would be interested if this was a real thing, I would be looking at, well, how many opportunities to make a mistake are there? Like if the top one has like 10 opportunities and the bottom one has 2, you have to look at it, be kind of careful there. But if they have a similar number, like, well, one has 9 and one has, 6, I'd be like, well, there's enough opportunities that you can compare them fairly. But hey, we are seeing a pretty strong difference, right? So we see that there's a large delta Y. So the root cause could be active here. The root cause is active here in some fashion. Now we're going to make our family bigger, right? So we start out with just one order form and just part of the order form, then multiple parts of the order form. Now we're going to incorporate multiple orders. So in this case, this is elemental variation within cycles. And what we see is with order to order with the same requester, they're about the same, right? There's a similar number of incorrect data. They're not identical, but it's close. So we would be inclined to say, hey, the delta Y here is small. So the root cause is really not active. So the difference between the orders, whatever happened between these two orders, is not significant in driving, a change in the Y. Let's keep going, right? So we got order to order with the same requester. Well, let's look at it, the bigger family, and make it, again, we're still looking at attributes, but it's within the structure and person to person in the same group. So here we might look at 2 people in the same group who do the same job, making the orders. And what we see is, well, the first person made 8 orders and 8 of them are filled, 8 of them have errors. And then the second person did it and 6 orders and 6 errors. So the fraction of orders with incorrect data is basically the same as 100%, right? They're both producing orders with errors. So what are we going to conclude here? There's no delta Y, frankly. So that means the X that's causing the problem is not changing its value here, right? So we can't see it. All right, so we've gotten to the point where we're person to person in the same group. Let's look at group to group, right? So now again, we're in the structure. We have 2 different groups. It's kind of like having 2 different production lines. And what we see here, again, we're going to look at the fraction of orders with incorrect data. So basically, we're taking the person-to-person comparison that we just made. Now we're looking at group to group. And, they're within the same division. So the bad group, where those 2 guys came out of, we look at 20 orders and all 20 have bad. We go find another group, and what do we see here? It's like, wait, they did 12 orders, but none of them have errors. That's pretty important. That's a really big difference. So this is an extreme difference between groups. And what are we going to conclude from this? Well, our delta Y is large and, the root cause is active. So now our investigation, right? We haven't yet started. This is the first step of our root cause analysis, is trying to figure out where do we look. And when you see something like this, you go, whoa, there's something here, right? there is something here that we have one group that's makes errors and everything, and there's another group that doesn't. And, you know, even though this particular example is fictitious, I have seen this situation, where it's like, why does one group not have any issues at all, and the other group, they're just like dying? It can be very illuminating. So if we'll summarize this, there are three strata with large delta Y in this particular example. We saw that within one category, there were, fields with incorrect data, and then there were fields that had correct data. And then if we looked at, again, on just one of the bad reports, there were parts that were bad, but then there were parts that were good, and there's a big difference. And then, of course, we saw that between groups, we have a really, bad group and a really good group. So if I were to attack this problem, I would be looking, normally I would say go after the smallest family of variation. But in transactional problems, a lot of times you're talking about some kind of system failure, right? Oftentimes, the people who are doing the job are working in a process that's never been optimized. And so you can look at the small one, but in reality, when you see the larger group, you say, oh, wait, the larger group actually has better leverage. Because I can figure out, well, okay, what are they filling out wrong here? But I see one group does good and one group doesn't. And that has a lot more benefit and power in the improvement process. So I'd probably go look at that. Again, normally I want to attack the smallest one, the smallest family, because it's the fastest, the easiest. But in transactional, I'm a lot more flexible because I look at thinking, okay, systemically, where's the best opportunity? And which one's going to give me the strongest clues to fix the system? So again, this is a case where I'd actually go after the biggest family, which is, quite the opposite of what I would have done with the flashlight example. I would have gone after the smallest family, although in that case it was also a big family. But yeah, the smallest family typically, but with transactional, you look at it systemically. So one of the things that you don't see here are the two families that didn't have much contrast, right? We're not even going to look at them. They're eliminated, right? So we've eliminated them. We're not going to look at them. Again, that's the power of the process of elimination is once you've eliminated, you're not going back unless you figure out that your data collection was wanting. So some thoughts on stratification. It's really useful in a crisis because it clarifies and narrows the search. And unjustifiable causes are quickly dispatched. So what does that mean? As I said earlier, there are people who show up and they have a cause that's looking for a problem. They want to change something. They say, oh, it's got to be this. And it's like hold on. When we do the stratification, the data shows that whatever it is you want is not in the group that has the strongest delta Y, the maximum delta Y. Because I've had plenty of cases where, there's a problem in the plant on a product that's been running good for years. And they're like, oh, we got to change the design. I'm like, why would you change the design? You've been making this for 7 years and the quality is really great, but now you want to change the design? No, we need to figure out what we changed in the last 2 months or whatever that's caused this problem. But they'll be like, no, you got to change the design, and sometimes when there is a design change, they try to fix it in process. But again, it's because the problem solving, strategy they're using isn't necessarily that effective. So, but this helps us like decide, oh, okay, the problem is over here. It's within this group of X's, and that's how we're going to attack it. One more thing. A single failure mode can have multiple causes. So if you've ever done a failure mode effects analysis, you come up, oh, here's the failure mode and these are the possible causes, right? You generally have several. It's not unusual to have 2, 3, 4. And so if you have a problem, you kind of have to make sure that you are attacking the biggest delta Y first. And I want to, an example that happened with me is we had these prototype parts. We were doing we were doing prototype samples for um, it was going to be an oil control valve, and as part of the assembly process, because it's supposed to contain the oil, we put an air leak test, right, just to make sure it's not leaking. And I don't know, it's like 10 cc per minute max. And they put some of the prototype parts when they tested them, it read 10 cc's. I mean, it was way more than 10 cc's. Whatever the pressure was, it could blow out way more than 10 cc's. But that's what it's reading because that the meter couldn't read any higher. And so as we did our investigation, we figured out that there was some of the parts that had been supplied. The shell was a stamped metal piece, and the supplier, the prototype parts, had not set up their equipment right, and so there were cracks in that metal. And if you didn't look for them, you didn't find them. But if you looked for them, you found them. And so when we found that, then we continued our prototype part testing, and we were still failing some, but they were failing for much lower uh, values. So, like in this particular graph shows, we had the ones that were at the maximum. We dealt with that problem first, and once we had that dealt with, we could see that there was still a problem. It was still leak, but it turned out that it was an issue with like the O-ring groove on the part, and that was driving a little bit out of limits the leak. You know, but again, the same failure mode, leak, but there were multiple causes, and so you have to be mindful that um, you can solve it, right? You knock down most of it, but there's still some residual, and that residual could be, oh, it's a different cause for the same Y, right? It's like, oh yeah, we knocked out our X6, going back to our original example, but we still have an X3 that isn't dealt with. So, as I said, deal with one, then the other. If again, deal with the maximums, then if once you get rid of that, then you have a new maximum, hopefully a lot smaller for your, or delta Y is a lot smaller. So let's summarize. Stratification analysis is a tool, right? We use it at the root cause analysis stage. It should be like the first thing you do with the Y that you defined is like, let's look at the pattern of where do we see large delta Y, and then let's apply the process of elimination. Looking at this, we should be able to see where we don't need to investigate, and as well as seeing where we should investigate. And there's a different strata, families, elemental, cyclical, structural, temporal. So if you think about, well, what can it be within a single unit? What is it as cycling it? Um, what is it structurally in the processes? So or temporally, like time to time, what happens? But if you keep those in mind, you can set up your approach, and then you want to investigate the strata where you find the delta Y max. And I didn't say it here, but where you think you can have the maximum leverage, where the maximum impact. Generally, it should be the smallest family, but as I said, with transactional, it's not necessarily the case. And of course, resolve the delta Y max first, because again, it's possible to have more than one failure mode or failure cause active, but you got to kill the big ones in order to find the smaller ones. So with that, that is my talk on stratification analysis. I don't know if any of you have any questions.
Thanks, one, Keith. Like always, really appreciate it. I, I had I don't know if it's, maybe it's a comment, maybe it's a question. You mentioned the example of the valve when you said it was a prototype,
Yes,
and then you did mention that you found out that there was a groove issue, right? That it was incorrect. So was that a design issue, or you found out that because of the process that you were doing, it
it,
was the
it,
fact that it was being tested incorrectly,
it was actually a sample. It was a prototype part component
right?
quality issue. The design was okay. It was just that the prototype parts were not okay. And it's
Okay. It's a prototype, right?
It's a prototype, right?
Right.
And they don't the suppliers don't necessarily have their strongest quality controls in place.
Comes to that.
And with the shell, the provider of the shell, the one that had the crack that was causing all of the high leaks. I mean, they were a very capable supplier. It was just, they got a little sloppy.
Floppy.
Um,
Yep, heard that before. Thanks.
So, great presentation, Keith. As Sergio mentioned, it's always really interesting
well, thank you.
listening to your any topic that you present is really, really great, eye-opening. So the question that I have for you is how to overcome or how to change. Actually, I think that's a cultural problem that we have, right? I call it the expert syndrome, right? We already know the solution of every single problem that we have. So everybody's an expert, right? You don't need to look for the root cause. It's that you, if this is the root cause of the problem. So how to change that in an organization, right? Because we want solutions right away, and analysis will take time, right? And so how to overcome those cultural obstacles that we have.
I have a strategy to propose.
Mhm.
Okay, so there's in the United States, when you do just uncontrolled guessing, we call that shotgunning. Like, I don't know your familiarity with firearms, but a shotgun just throws out a cloud of pellets, that you use them to hunt for birds, right? So, as the bird's flying through the air and you fire your shotgun at it, that cloud of pellets, you hope one of them is fatal to the bird and bring it out of the sky, right? Because if you try shooting a bird with a rifle, it's, that one single shot, it tends to be low, low reward. But when it comes to solving problems, a lot of people just, start, throwing whatever they can. We say throw things at the wall. It's the same thing as shotgun, right? You just throw a lot of stuff and hopefully something does it. But what I would say is when people are going to solve a problem, and it's important, somebody's got to show up and say, okay, if I go to a team that's like fighting to solve a problem, I'm going to ask them, what do you guys think is the cause? And then if nobody agrees, then we clearly need to do something structured. But if the team or let's say the guy with the biggest salary has an idea, right? The person at the top of the poll, you're going to say, okay, well, if you think you know what it is, let's just run the confirmation test. And so that was introduced to me as rifle shot. You get a bullet, one, and you can shoot. And if you miss, you have to go and do a structured because clearly you don't know what's going on. If you actually understand your process and you say, oh, this is deviating in this fashion, then okay, let's go make the correction that you, based on your experience and knowledge and judgment, say is the thing to do. And if you're right, we're done. That's super fast. And my personal view is I don't want to write a report. I don't like generating a Six Sigma report or a Shainin Red X report or an 8D report for the sake of it. I'm doing it because it's necessary, or somebody demands it because we can't get the problem solved. But if you show up and they say, okay, the team is agreed. The problem is that, this machine is out of adjustment. Okay, let's put it into adjustment. And you guys say, if it's adjusted, everything's, our problem is going to go away. And you make the adjustment and the problem doesn't go away. All right, guys, you obviously don't know what you're talking about. And that's really, really important. They have to put themselves on the line. I mean, and it's partly your task as the person kind of pushing them is like, you guys say this, let's write it down. You say, if we make this change, this is the result. But if it doesn't work, you don't get a second chance because clearly you don't know what you're doing. We have to follow a disciplined, structured process after this because you guys have already shown us. And then, they do it and it fails and they go, oh, no, no, no. Now I see this. It's this other thing. It's like, yeah, no, right? This is, you guys said you knew what you were doing. I gave you a chance. You've used your chance. We cannot tolerate this. And customers go nuts I mean, and if you've been a customer and you've gone to, I don't know, probably sat here, you've been at a few places where you said, well, this isn't working. What's going on? Well, it's this thing. And then, okay, well, how come it's not working yet? And then, well, maybe it's this other thing. And then, it terrifies me. It terrifies me because they start to change a lot of things and things they shouldn't change. And then you're like, hold it, guys, you're turning too many knobs that you shouldn't be turning, and you're probably not keeping notes. You don't know what your setup is. And then, they change this, change that, and they get desperate. It's like, no. We have to push. But the first thing is let them hang themselves. Now, if they're right, we're all happy. But if they're wrong, we cannot let them forget that they were wrong and that we have to follow the process. Because, if you follow the process, it'll take a few steps, but you will get to the answer. If you just guess, you may not be learning anything. You're not being systematic. I mean, if we step back and say, what is problem solving? Problem solving is just a learning process. Something bad happened, and if we understood why it went bad, well, we wouldn't have let it go bad unless we're sloppy and lazy. And sloppy and lazy is all over the place, so there's plenty of that. But again, my view is, okay, I'm perfectly open. If you think you know the answer, and again, it breaks down into if the person with all of the power and influence wants it, says this is it. Well, okay, guy, we have to knock down that psychological obstacle. We can't come in and say, no, you got to do it my way. You have to let them try to be successful. Because if you don't, they're going to be undermining you left, right, and center. They're going to be doing malicious compliance. They're going to slow walk stuff. They're going to talk bad about you behind your back, and you just be like, so the thing you got to do is say, all right, well, you guys are convinced, or the most powerful person in the room says this, let's do it. Let's run the confirmation test. But if the confirmation test does not pass, clearly we don't know what's going on, and we have to follow, a structured, rigorous process. So that's my recommendation.
Thank you, Keith. Thank you very much. Yeah, I like that approach.
Yeah, I mean, and you don't have to be a super jerk about it, but you do have to you do have to keep reminding them of their failure. I mean, it's just like, hold on, you can't. I already let you try this. Like, here's the data. We did what you told us to do, and it didn't work. So clearly, we don't know, and we need to go through this learning process of problem solving. So, Orpha, you had a question?
Yes, well, first of all, thank you for bringing us to this kind of analysis. I never seen it before. The new thing for me, is the stratification analysis, of course, because the root cause analysis, everybody is involved in it. But the stratification is interesting. My question to you, can a system like this could be something systemic in a manufacturing environment in such a way that the people from the manufacturing areas can conduct it?
Oh, totally. I mean, the hard thing about doing stratification analysis is like being able to partition into like, well, what's the smallest family and what's most people don't understand their processes that well.
Yeah.
And it's like a lot of people just show up to work and push buttons, right? They're as Lonnie Wilson likes to say, they are not engaged. Lonnie really architects. I think most of us know Lonnie, and Lonnie is just his thing is workforce engagement, and but too many people are showing up, and you say, okay, well, what am I supposed to do? I left my brain at home, but my body is here, and tell me what to do, what to think, right? But
Okay.
but yeah, it can be taught, and I think it must be taught, and it's certainly learnable. I mean, if you're in an environment, you can,
Yeah.
it's
And the thing is, I'm thinking about how can you make it a procedure so everybody can use it? See what I'm talking about? Because you show us different examples with different approach, right? So
Yes.
this training to the people and instructions in a procedure must be very conceptual, right? In order to apply it to many cases, right? Many circumstances.
Oh, yes, the challenge is I think about this all the time, right? I mean, it's just like I think about this all of the time, and I recognize that that is unusual, right? Most people don't, but I have seen how it can be taught, and in reality, few workplaces do effective training, right?
Really?
As far as like upping skill levels, and it's unstructured. Most training is informal, like, okay, how do you do this? In the example I was showing of the order form, um with transactional processes, I have seen so many cases where people learn how to use a system by like sticking crap in it, and it didn't get rejected, so they keep doing that. And then they show somebody else how to do that. And
Mm-hmm.
there was one data there was this one thing, like when I was at Delphi, where to get people to have access to one of the computer systems, somebody figured out when they couldn't get it to work, they created a new database.
Yeah,
So they created a copy of the database. And
yeah,
by the time we did a project to figure out what was actually wrong, to get a new person put on it, it took over an hour because there were 13 databases, right?
yeah,
They came up with a terrible bandage that said, "Oh, well, now I'm struggling. Oh, well, let me just create a new database." But you have to keep all versions of them up to date. And so, you sit there like, what kind of logic got them there,
yeah.
right?
You know,
So,
I like your example with the documents where you see mistakes in several areas, right, in the
mhm,
document. You know, and I used to live with the same issue for many years, especially in medical devices.
mhm.
And that's why we used to have on a screen all the time, four people reviewing all the set of documentation before to put it, in a batch record for a medical device information. So, and many people used to have almost exactly the same mistakes filling those forms. So I like the concept that you gave us, that take a look at the delta Y, what is the maximum? And that's the first thing you need to avoid, right?
Yeah. Well,
Okay.
the
Because
maximum delta
there are going to be
Y.
many.
Well, see, that maximum delta Y is something a lot of people miss, right? And in fact, when I learned it in the Shainin method, Shainin uses trademark terminology, and what they do is they call it Bob and Wow. And the problem with calling things Bob and Wow is Bob means best of the best, and Wow means worst of the worst. But we need
Hmm.
the maximum delta Y. So literally, it's 100% rework as a coach, right? I mean, I don't know, I've certified 200 plus apprentice candidates. It's
Okay.
100% rework, because when they say Bob and Wow, if you have that target, like that target value, everybody thinks that's Bob, because that's best of the best, because that's the target. It's like, no, 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 no. We want the extremes. And so, being able to understand that the target is of interest, specifications are of interest, but what we really want is to look not at specs. We want to look at the population, and we want to look at the limits, because those two, the pieces from the edges are the most different from each other. And if we can understand how are they almost alike except for this important difference. And again, that's what the stratification analysis helps you do, is like figure out, where do I see that they're completely different, but they're closely related. So, we see cases where, like in dealing with parts, where you have one part and sometimes it's good and sometimes it's bad. Well, then you're like, oh, the thing that causes it to go between the extremes lives inside of this one part. I don't have to have 50 parts. I can do it with one
Hmm.
part. Maybe I get a part that doesn't vary, and then I can do part swapping and see, well, when I switch which part, when does the variation move to the part that was consistent. But yeah, that it's
Yep.
it's a delta. It's delta y equal to a function of delta x. That's a really important
Yeah.
concept to adopt.
No, I think this methodology have a great value.
Oh yeah.
Thank you.
I think Hector posted a question on the chat, Keith.
Okay. Hold on, let me.
There are two questions actually.
Right.
Let's see. Okay, are all the tasks from concept through detailed design engineering to production launch technical or transactional? They're a mix. They're a mix. Because what happens is like documentation type stuff, analysis, all analysis is transactional. It's about information. But then when you're actually building parts, that's going to be technical when you're running. So you have both of them, and that's why I argue that even in a manufacturing environment, most of your processes are transactional. You're mostly dealing with data. It's amazing nowadays how much data gets collected. Like at Dish, when you see all the tests that they run and so forth, you're like, okay, well, is that is that technical or is that, transactional? And I would make the argument that once you get test data, it's moved out of the realm of technical into transactional. But as long as it's sitting on the test stand, we're talking technical, right? Is it getting the right signal? Is it getting the right frequencies? Is it mechanically connected correctly? Those are all technical things. But then once you have data, it's entered the realm of transactional. Like, okay, well, let's process the data, let's analyze it, let's look for the, the control charting and so forth. And then you had another question. The same question is from the physical transformation of raw materials to a finished product in the hands of a customer. Is it technical? Again, it's a mix. Every step of the way, you're going to be having both. Because let's face it, you do 50 processes a day. Some of them. If you work on a line, let's say you're you are an operator on a line. You're doing what would be considered a physical, technical task. But if you start recording data about it, you've moved into the transactional realm. And of course, there's like maintenance crews. They are principally service. They're principally transactional. Although they do stuff that you would say, oh yeah, it's technical, it's physical, but it's principally service. What's valuable about them is their knowledge. That gets us into, the transactional.
Thank you.
So, Orfeo?
Agree. Yeah, one quick question. Keith, have you seen this methodology or process implemented somewhere, already in place?
You mean doing stratification analysis?
Yeah.
Well, I have to say, as I said, I learned it through the Shainin Red X method. So like when I was at Delphi, it was white, there were certain groups that were pretty deep, with highly skilled that would do it all the time. So yeah,
Okay.
that's where I've seen it the most.
Okay.
But again, they've built that into their process, their methodology, but it's
But the good thing is that this can be applied almost everywhere, right?
Mm-hmm. Oh yeah. Well, the process elimination thinking is what's really key. Is to say, okay, what clues can I get so I can say it's not here? And like I sometimes do when I do training about process elimination, I use a deck of cards, and because everybody is familiar with playing poker cards, and it's like if you answer a question like, is the card red, and the answer is no, you've eliminated half the deck. Like, so if somebody guesses, well, is it a Queen of Hearts? It's like, we already eliminated red.
Right.
So, either you don't know what cards are, you don't understand the card, which does happen. People don't know their systems. But if you say, wait a second, we've eliminated that. We're not going to guess that it's the Queen of Hearts. And in that same thing, if you ask the right questions, 100% of the time, you know what the card is. Like if it's, so, you know, pick a random card out of it within 7 questions. Sometimes as few as 5. It depends. There's a couple of questions that can increase it 1 or 2 depending on the answer, but yeah, it's 5 or 7 questions will 100% of the time get you the answer. Now, here's the thing I tell people though: if you get lucky and you guess correctly, that is the very fastest way to get to the end. If you get lucky. But the problem with luck is it always runs out. You know, so what you'll find is people get habituated, like, because let's face it, most problems we see are retreads. We've had them before and we just didn't kill them well, and or you know, some problems just that becomes their job, is just to paste over the problem every time. You know, put a new Band-Aid on it today. You know, some people really think that their work is to apply Band-Aids, but if you go into this saying, okay, I am going to figure out what it isn't, I will get to the answer quickly. And that's the thing that we've got to teach people is, you know, it everybody's accustomed to guessing, because most of the problems we face are things we know. Like if my light doesn't turn on, I can guess that the light bulb is burned out, right? I mean, because the light bulb is the fuse. The fuse is what usually fails. But I will tell you this, one time I had a light that wouldn't turn on in my house, and I spent about $50, and I was to the point where I was going to call an electrician because I couldn't get the light to go on. And then it turned out that my parents had, the light would sometimes work and not work when my parents were here. And then when they left, it just wasn't working. And I was looking, you know, one day I was like, you know, after I had bought switches and I'd bought new light bulbs and, you know, I'd gone through all kinds of hassle. And then I was looking across the room by the door out of my house, and there's 3 light switches. Well, this particular light, the switch by the door and the light that the switch that we use to turn it on, both, for the light to turn on, both of them have to be on. And I realized, wait, my parents turned it off. And I never check it because I always leave it on. But my parents were here, you know, the outdoor lights, they would turn them on and off, and they're all together, so they would turn them all off. You know, so again, sometimes, you know, it's like the easy thing didn't work, and you know, it happens. It happens.
It's a
So
person to person.
yeah.
Keith, let me ask you a question. Have you seen this book?
Yes, I have.
Okay, because they're supposed to give us all the tools, you know, that exist supporting the quality systems. Have you seen it over here? I haven't seen it. The
What do you mean?
stratification analysis.
I've never looked. I mean, I've seen the book. I've looked at some of it. I'm actually not the biggest fan of the book because I don't really feel like the explanations aren't enough to use most of the tools. And that's like, okay, you can look it up, but you're gonna need help.
I was asking you because I like to dive a little bit more on this concept.
Mm-hmm.
Obviously, we're going to have a copy of your presentation, but you know, that's interesting. Interesting topic.
Well, I'll tell you this, Orville. You come up with a problem, and I'm happy to you know, talk with you about like how I would strategize for it, to you know, to give you that. So you know, I see that Luis had said here, you know, no budget for training, it's the first thing to removing reduction cost. That was a problem that I had at Delphi. And it was one of those things where I'm like, you know, when I started in the continuous improvement group, we did all of our training with external consultants. And I'm like, you know, I hadn't been in the automotive, well, I've been in the automotive industry enough. I was like, you know, when the cycle goes down, there's no training. But because, you know, we're in Mexico and we have regular turnover in staff, our training need never goes away. So we had to, you know, I was of a mind that we had to have self-sufficiency.
It's an issue.
And so, you know, but there was one group that the engineering manager told his team, like, problem solving is the #1 skill of an engineer. And so he put, you know, some wood behind the arrow they had a weekly seminar, 1 hour a week, where one person from his team had to present on one of the problem solving tools from the Shainin Red X method. And then one team had to share their current problem solving project. So the team was seeing every week each other's work, and they had to explain the tool. And that particular team was just, they were self-sufficient. They were the team that was just producing. When I first joined the continuous improvement team, I didn't even have a certification. I mean, basically they give us their reports and we pass them on to the consultants because they were so, they were in this practice. And it didn't involve external consultants. It involved them, spending time seeing each other's project, which nobody volunteers to share their projects with other people. And that's a great loss. But if the teams would see each other's projects and be able to like suggest or criticize, the growth is enormous. I mean, again, that team was so exceptional. I mean,
Right.
they were crazy good.
There's a question from Steve in the
Oh, yeah?
chat. It's
Okay. Let's see. Do you find that many places allow variation in their processes? Do you find that many places allow variation in their process? I don't know if the word allow is right. I think a lot of places don't recognize variation. Because when I say, well, if you think about lean, where they talk about the 7 wastes and we're going to fight waste, I say waste is not the enemy. Right? Waste is not the enemy no more than a bullet and a bomb is the enemy to a soldier. Right? What is the enemy is variation. And it's hard to fight variation because it's a conceptual you have to have a conceptual mindset shift, a paradigm shift. It's variation that kills us. And a lot of people, like, again, when I was talking about teams out of control turning knobs and stuff, they don't understand the concept of tampering and how that amplifies variation. And so that's that's yeah, whether it's allowed, it's like out of control.
my wife
Yes,
wants.
Ivan. Yeah, Ivan?
Hi, Keith. I have a question here.
Mm-hmm.
Okay, so I had surgery in Trans Mountain, Providence.
Mhm.
Okay, so I gave them all of my information, all of my data, insurance, and everything. I had another operation, another surgery in Trans Mountain, Providence.
The same
And
place.
I said, I gave all of the information to the east. Just get it from there. And they said, we don't communicate. I said, but you're Providence. Well, we don't communicate. Whatever you did over there is the documentation. Over here, we need all of your documentation again. I'm going to get a survey. I see that as a transactional problem on informational service.
Yes.
Am I right?
Yes, you are.
So I said, you're going to get something to your leaders, to your managers, to your supervisors about this trend. The east is about 55 minutes from my house.
Yes.
We went twice. They were closed. Call us on Saturday. I called, it was closed. It was ridiculous. And I come over here, oh, we cannot connect your data to their data. I say, it's the same data. It's the same. We can't do that. It was frustrating.
Were they saying they couldn't do it because of policy or
one
regulation,
surgery-
or just they didn't have?
They just said that they're not doing it.
One surgery was in the east, and one surgery was in the Trans Mountain.
Trans Mountain.
Providence. Yeah.
Providence.
So that's why it's confusing for people.
Yes, the doctors have a network between both of the hospitals, but the documentation it's not in the network.
Well, that's because I see here that you put the question, how would you solve the problem, the transactional problem between the hospitals?
Why can I
And
tell them on the survey that they're gonna send me?
well, so the thing is like, hey, why why is my information, at one place and not the other? Are you not actually the same system, or so that would be my complaint is, hey, I put my information here. I thought you guys were the same company,
Right?
you know, and so therefore I think that the information would be shared. Is it why not? So but this
Okay.
brings in the question, like, at what level does this problem have to be attacked? Because if it's like a policy decision, right, where you start talking about, well, the chief information officer made decisions, or the chief executive officer made some decisions that, for investment reasons, for whatever reasons, they're not going to be connecting, right? But it feels odd. It feels odd in this day and age.
It does. It doesn't, it's not logical. It doesn't make any sense to me.
Well,
Providence
it's
is
because,
Providence.
well, also it's electronic. That's the other thing. It's
And it's
electronic.
electronic.
So,
It's a copy of my insurance. Just send it over there. No, we can't do that. We don't communicate. What? I was amazed.
yeah.
I was angry. And I said, you know what? From a 0 to 100, you get a 1. On
Okay.
communication skills between both of you, you get a 1. You're flunking with me. This is upsetting. Please record it. This is insane. It's not logical. So
Yeah. Well, because it's a real cost to you, right? When you say,
it
hey, I've got to
is
drive 55 minutes
55
twice,
minutes back and forth 4 times, and they were closed. One was closed, and the other one she didn't work on Friday. So what? Nobody
yeah,
else can help me? No, nobody else
yeah.
in the whole hospital. Registration, somebody. No,
Wow.
we don't touch those cases. What?
That's amazing.
It is amazing. And my sister works on the East, and she was furious. And she says, what are you doing here? I'm after these people. Why? Because they tell me to come and look, they're closing. She's not working. And oh my God. I say, yes, ma'am. Oh my God. Yeah, so, okay, thank you for your ideas. I will go ahead and put it in the survey and see what they tell me.
Yeah. They probably don't have enough people complaining about it yet.
Probably they are like, it's done, but I'm not thinking just of me, but other people that are in my same position. We live in the West and we have to go for the surgery on the East. So we're gonna have to go back and forth with the data? What?
Well, what happens in these cases a lot of times, and I see that, is that, I talked about the ladder of abstraction.
Uh-huh.
One of the real dangers, like somebody the last time I did this presentation, they made a comment about big data, but solving problems using big data generally isn't going to solve like real problems, because what happens is you tend to look at abstractions, and then you start looking at averages, and when I'm talking about the delta Y max, we aren't looking
Uh-huh.
at we're not looking at the whole group. I'm not looking at an average of the group. I'm looking at the most extreme and saying, well, what works in this case, and why are they so different?
Why are they so different? That's the question.
Like in your case, if they say, oh, well, you know what, we did the survey, we surveyed, we've had 2,000 patients in the last month. 2% answered the survey, which is pretty typical. So that's like 40 people, who've answered the survey. And, one of the 40 complained about this communication thing. So that's like, 2.5%. Oh,
They
we
don't
have
take it seriously.
2.5%.
Mm-hmm.
Yeah, but they're not looking
Yes.
at the extremity of it and saying, well, how much inconvenience did we impose? And so that's one of those problems that you face, especially as you start looking at CEOs, the C-suite kinds of folks are anesthetized, right? Because they're dealing with the abstract things, profit, loss, you
Profit.
know, turnovers. They're looking at not at individuals. They're looking at just rolled up data where the humanity has been squeezed out of it. And something
Most likely.
you know, something that I say is, you know, like one time we had a product that had an inherent defect, and it was put onto commercial equipment, like farming equipment. And, you know, basically 100% were going to fail within their warranty life, almost 100%. And the thing is like they park this equipment and then they use it, you know, it's farm equipment. They'll use it every single day, but when they need to use it, they need to use it. And to get back, I mean, these things were about the size of a brick. They were coming back to us in these baskets that were like, you know, holding several hundred at a time. And you're like, wow, every single one of those. I mean, it gets to the point where we say, oh, yeah, you know, we got 500 back. You look at it and you say, you know, that's 500.
It's a lot.
It's a lot. But what you don't think about is every
Comparing
single
it.
one of those is some farmer someplace was seriously inconvenienced. That maybe they had to work extra, maybe they had to pay overtime to people because their equipment didn't work. They had to go get this part swapped out. You know, they had to have somebody show up and do the fix. So it's costing this money and it's doing all this other stuff. And what they need is reliability, right? But it's hard to see when you just get these boxes come in. Oh, okay, well, we have a 10, 15, 20, 30%, you know, return rate this month. You know, where you're saying, okay, well, you know, it's going to cost us X dollars, but again, the humanity's been squeezed out where you're saying, wait a second, there's a guy, there's a woman, there's a family, there's a business that's been profoundly disrupted. And so as I
And
said,
it's true because I even talked to the ladies from the cafeteria and I went like, oh my God, all of this food. And look at this. It looks so nice and it tastes better. Oh, really? I said, this is good food. Thank you very much. They said, well, we got a chef and they came and told us how to do the nutrients. But I said, it's a lot of quantity and it tastes so good. So when I got that survey from the East, that's what I said. But after I had the surgery on Trans Mountain, I said, no, your communication, you get a 1% out of 100. You're failing. You're failing. And it's true. They said, oh, we didn't know that our food was good because we get the surveys and we put it in the trash can. Oh, I'm done with that. Forget it. I don't have to do it. Even if you have the envelopes, you know, ready to be sent and everything, we tend to be like lazy, like you said, inconvenience, lazy. Forget about it. I said, no, I'm going to wait for your survey and give you a 1% out of 100. You're failing. I told them. Because when they do right, I want them to see that they're doing right. But when they're doing wrong, I want them to know that they're doing wrong. And I'm going to go ahead and say all of that, right?
Yeah.
Not because I'm a 1% of the survey returning, this is what's going on. And yeah, I'm going to even type it so I can paste it there and have enough information so they can see what they're doing to people.
Yeah.
Important. I know numbers, logistics, and the whole thing. Yes. But the service is so important. The service.
Again, that's one of the things we have to emphasize is if you take the humanity out, you know, you lose. And we see that, you know, we see that things like, you know, again, the current whipping boy is Boeing. You know, when they redid their contract with their machinists in 2014, they screwed themselves, you know, because they are like, oh, the executive is going to be the enemy of the, you know, frontline employee. And it's like, how does that work? How does that work to build a sustainable company? Well, it's because, hey, we got to do costs. You know, again, they're abstracting it out, saying, well, we're looking just at cost. We're looking at profit, you know, stock buybacks, whatever.
That's not service.
But we're losing sight of where does the value come from? And so, you know, like in your case, you're saying, well, what creates satisfaction for me is like, I don't have to be inconvenienced. And you're inconveniencing me. And then people are throwing up their hands and saying, oh, you know what? It's your problem, not our problem.
No, it's their problem.
Yeah, it is their problem. I agree.
It is their problem.
Ivan,
I say, so you're like the Twin Towers FBI is not talking to CIA, and then you've got the problems. There goes the twin pro. Oh my goodness, we should have communicated. I said, wake up, guys, and smell the roses.
Well, Fonz
Communicate.
has put in some places for to
chat.
connect with in
You might
the
want to
chat.
get that information, Ivan. He put something on the chat. Alfonso did.
Oh, you
Yeah.
put something on the chat. Sorry. It's so.
Well, we are at 8 o'clock, so
Yes. Sorry, guys.
I don't know if there's any last questions or comments or.
Good job again. Thanks a lot, Keith. Really appreciate it.
Yes,
Well,
very nice.
Thank you, thank you. I'm glad I had a chance to go further with this than the last time than I did it with
Yes.
Thanks for
Austin.
bailing us out again, like we always do. Thanks.
Well, it's good for me. I really wanted to continue the thought process on this, so I like to. So I'm happy to.
I'm
uh,
telling
Good-
I apply it to
good
everything.
presentation.
Yes,
All
very
right.
nice.
Well, thanks everybody. Good
Thank
night,
you,
and
guys.
we'll
Thank you,
hopefully see
Sergio.
y'all next month.
Thank you, Keith.
Good night.
Good night.
Thank you.
Yeah.
Good night.
Thank you,
Night.
guys. Bye.
Bye-bye.
Thank you. Good night.
Okay.